Yeah, okay. So now in this sum, we just need to find the Lorentz series for these given regions. We don't need to think much, just go ahead and do. So this is case 1, 2, 3. Okay. Firstly, we just need to break down the function using partial fractions. And before that, we need to just simplify. I'll get rid of this. So this equal to, we are simplifying the denominator. Okay. So we have z square plus 4z plus 3. So we could write it as z square plus 3z plus z plus 3. So if we take stuff common, we'll get 1 upon z plus 3 and 1 upon z plus 1, if I'm correct. So the roots are minus 1 and 3, minus 3. I'll just cross check though. Don't want to mess up. Yep, minus 1 and minus 3. Nice. So now we could use partial fractions on this. Okay. So we just do t is equal to a upon z plus 3 plus b upon z plus 1. Nice this is. Okay. So now in order to solve this further, this is a. Okay. Yeah. Now we cross multiply, so we get a z plus 1 plus b into z plus 3. Nice. Okay, now we could put z ka value minus 1. This will go down to 0. We put minus 1 here, we will get 2. Okay, so we get b ka value as 1 by 2. Nice and easy. And now we can put z ka value as minus 3. If we put minus 3, this thing becomes 0 and this thing will become minus 3 plus 1 minus 2. And if we take minus 2 to the other side, we get minus 1 by 2. A is equal to minus 1 by 2. Nice. Okay. So we got a and b partial fractions. You could write by partial fractions also if you wanted to. Now we could basically directly start with case 1, where mod of z is less than 1. Also our function would be, I forgot to rewrite the function only. Our function would now become from here, okay, not from here, from here. Now a new function would be, it's the same function only, but expressed as fractions. Meeps. I'm taking half common out. So we get minus 1 upon z plus 3 plus 1 upon z plus 1. I just took the half common out. Otherwise, it would be basically the same. Minus half, and when we take the half here, we'll get plus half as a and b. Now for mod of z is less than 1. Yeah, okay. We needed to write the thing in less than 1 ka form, no? So we already have that. We just need to get these things in the form. This thing could be rewritten as 1 upon 1 plus z. So our work here is done. Over here, we need to take 3 common now. So we'll get 1 plus z by 3, and a 3 would be here, like 1 by 3 basically, but 3. So our function would now become half times minus 1 by 3 into 1 upon 1 plus z by 3 plus 1 upon 1 plus z. This is just rearranged, nothing else was done to this one. Lol. Okay, so now since we know mod of z is less than 1, now if you divide both by 3, okay, so we know mod of z by 3 should be less than 1 by 3, and we also know that 1 by 3 is less than 1. Therefore you can say that mod of z by 3 is also less than 1. So this is less than 1 and this is less than 1. That's all we needed, I guess. So now we can write it as half times minus 1 by 3 into 1 upon 1 plus x, so the standard expansion, plus minus minus z by 3 plus z square by 3 square minus dot 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 plus 1 upon, oh sorry, not 1 upon, just this is also 1 upon 1 plus x ka form, so 1 minus z plus z square minus z cube dot dot dot. If you want, you can simplify this. I just leave it as it is. That is a case number 1 done. This is our needed Lorentz series. Then for case number 2, we have, what do you say? For case 2, we have mod of z is between 1 and 3. Okay, so mod of z greater than 1, less than 3. Okay, so now we can do what? Yeah, just solve like this. Firstly, I'm not rewriting the function because it's right here. Where did it go? Yeah, yeah, okay, yeah. So we need to write these two things. We get one condition at this and one condition at this. Okay, so we need to write a less than 1 ka form. So we could just divide it by mod of z. So we get something is less than 1. Here also we need something is less than 1. So something is less than 1 ke liye we divide by 3. So we get something is less than 1, something is less than 1. This will help us use our expansions in the function. So here we get 1 by z, no? So where can we get 1 by z? We could get 1 by z over here, no? If we take z common out. So it's for this term. So we'll take a z common out. So we get 1 plus 1 by z with a z outside. Here, as a. And for this one, we need z by 3 is less than 1. So we could just take 3 common out like we did previously. So we'll get minus 1 by 3 here and 1 plus z by 3. Kinda like this one only. Only this one would be different. So now our function would become half times what? There's minus 1 by 3 because you took 3 out. So 1 plus z by 3. And the other one would be plus we took 1 by z out common from here. Okay, sorry, z out common. So we'll get 1 plus 1 by z. Now we already know that 1 by z is less than 1 and z by 3 is less than 1. So our conditions for the 1 plus x expansions are satisfied. So now we could just directly expand it. Oof, this is z by the way. Lol. Meep. Should have gotten the hang of this by now. Plus minus plus minus. Dot plus 1 by z 1 minus 1 by z plus 1 by z square minus 1 by z cube. Okay, इसका भी expansion. Yeah, I guess we are basically done with case 2 as well. Now for case number 3, we were given mod of z is greater than 3. Mod of z is greater than 3 and our original function was half into minus 1 upon z plus 3 plus 1 upon z plus 2. Sorry, z plus 1. Yeah, okay. So now we have mod of z is greater than 3. We need to write it in the form of 1. We need 1 on one side, okay? And 1 greater than something. So we could just shift this over here. We'll get 1 greater than 3 by mod of z. Okay. And if you want, you could directly write this, okay? 1 is also less than 1 by z. It's basically inferred from this only. So now we need a term 3 by z. So we'll be taking z common out here and we'll be getting 1 by z term. So we'll be taking z common out here. Okay. So we get 1 by 2 minus 1 by z we took common out. We get 1 plus 3 by z plus over here we also take z out. So 1 by z into 1 plus 1 by z. Nice. So now we could take the z common out as well. My z and 2 almost look the same for some reason. Wow. And we get minus 1 upon 1 plus 3 by z plus 1 upon 1 plus 1 by z. Yeah, okay. And now finally, we could use our expansion since the 3 by z should be less than 1. We already have that satisfied and 1 by z should be less than 1. Even that is satisfied. So now we could just solve by expanding. There's a minus sign here. And then we get 1 minus, this is 1 upon 1 plus x ka expansion. This is normal stuff. Alternating plus minus signs. Same over here. Yeah, okay, and if you want, you can simplify this further. This is a Lorentz series expansion for the third case also. And I guess the numerical is done.